Hi everyone, this is Dr. Nally. So this is the second part of the series of videos talking about, different properties of matter and how we can separate them. So in this second video, I'll be talking about the composition of matter as well as separation methods. So as I mentioned before in a prior video, that in chemistry what we study is what we refer to as matter, which is basically just something with a mass and has velocity. So you can think of basically anything around you as matter. The lampshade, air around you, water that you drink, any kind of coffee that you drink, the blood in your body, skin, all of those are matter because they all have mass and the particles are moving at a certain velocity. You might not think about it about things like solids, but there are actually vibrational motion in those molecules that compose a solid. Now, what we want to talk about now is just how chemists break down matter, because it's a little too complicated to just think about matter as one substance. So you have to kind of think about what it is the matter is made out of or is composed of. Okay, so the first thing is just to break it down fairly simply into two things, which is something called a pure substance and something called a mixture. So a pure substance basically just has one chemical identity, one chemical component. So for example, hydrogen gas alone, like pure hydrogen gas, would be a pure substance. Okay, helium gas that fills up balloons, that would be a pure substance. Now, water will also be a pure substance. You just have pure water, nothing else in the water, then that's a pure substance as well. Okay, it only has one chemical component. Whereas a mixture basically has more than one chemical component. So, water, sugar water, Coke, Coca-Cola, beer, air, all of those are mixtures. Air is composed of CO2, oxygen, nitrogen, and so on. So it's a mixture of gases. Steel, which is a mixture of carbon, nickel, and so on, and iron. Those that's a mixture as well. Okay, now once we divide the matter into pure substance and mixture, we can then think a little bit further about the pure substance part of it, which is to separate it into something called just element versus compound. An element would be basically a species that, or a substance, a pure substance that only contains one chemical element, i.e. hydrogen alone, or helium alone, or oxygen alone, and so on. So things like oxygen gas only contains oxygen in it, so that would be referred to as an element. And helium obviously is just helium alone, so that's also an element. Iron, pure iron, that's just an element as well because there's nothing else in there, so that's called element. Compounds, on the other hand, are pure substances that contain more than one element. So for example, you might have water. And remember from the previous video, we talked about water having the formula H2O. So that means there's two elements in there. There's the hydrogen element and there's the oxygen element. So the compound contains two elements. Now, you can try to take the compound and separate it into the separate elements, right? Take water and, convert it to hydrogen and oxygen. They're in the water. But that's usually quite difficult to do, and you need a chemical process in order to do that. Okay, so that's kind of the idea here. To convert compound to element, you need a chemical change. Okay, you need some kind of a reaction, a chemical reaction, to break apart the two things, two or more things that are in one compound into element. Now, the other thing that's a compound is things like sodium chloride, NaCl, your table salt at home. That's also a compound because it's pure on its own. If the salt is pure salt, then it's just NaCl, pure table salt. But you can break it down into Na and Cl if you use a chemical reaction to separate them. Okay, so that's the difference between element and compound. Now on the mixture side, we can have either what we refer to as heterogeneous mixture or homogeneous mixture. So simplest way to kind of think about this is basically a homogeneous mixture is a mixture where it's hard to tell that it's a mixture. In other words, everything looks like it's one uniform phase. So like tea, like this, right, or sugar water, for example, is a homogeneous mixture because everything looks like there's just one phase. You can't see that there's two things in there, right? Sugar and water mixed well together. When you mix sugar and water, after everything is mixed, just looks like a clear solution. Now, in this case of tea, you have a lot of molecules in here. You have the molecules from the tea leaves. You have the sugar, maybe if you've added the sugar, you have water. So there's a lot of things in here, but it just looks like all one phase. However, in a heterogeneous mixture, you can tell that there's two different things in there. For example, sand and water, when they're mixed together, they don't mix, right? So you can clearly tell there's sand and there's water, okay? You'll see later on as we go through the semester, you'll see certain reactions that produce a solid, which we call a precipitate. And you can clearly see in your test tube that there's the clear part of that test tube, which is the solution part, and there's the solid part of the test tube, where like the substance forms a powder and settles at the bottom of the test tube, and that's referred to as the precipitate. So that's clearly a heterogeneous mixture. Now, whether a mixture is heterogeneous or homogeneous, usually one of the goals that we have at the very beginning is to try to separate them into the pure substances that make up the mixture. Okay. So we do this because we want to understand what it is, what's unique about each of these pure substances that make up the mixture. So what we want to do is take these guys and then separate them into pure substances. And in order to do that, we can do different types of methods, but they're all physical methods. In other words, they're basically relying on the idea that there are different, physical states perhaps that we can convert one substance to versus the other one, and that allows us to separate it. For example, converting one form to the solid and the other form to a liquid, and that allows us to separate then the solid and the liquid. Okay, but the separation of the mixture into pure substances rely on physical means, okay, or physical techniques, whereas remember earlier the separation of compounds into elements would require chemical methods. Okay, all right. So let's talk about some of these separation methods. I'm just going to go through them relatively quickly, I would say. The first one is fairly simple, which is separating a mixture that contains both solid and liquid states. So this is called filtration, and the setup looks something like this. This hopefully is fairly familiar to a lot of you, at least it's intuitive. Basically, the way you would do this is if you have in your beaker, for example, you have something that has both a solid and a liquid. You can set up a filter paper through a funnel like this, and the filter paper will trap the solid inside the paper, and it would let the liquid drip down to the bottom to a new beaker that you can then separate from the solid, right? Because the solid now is in the filter paper. This is basically the type of separation you do all the time. By the way, if you make coffee yourself at home, what you do is you usually grind the coffee beans, right? And then you put the beans on the filter paper, and then you pour hot water over it. And that's basically, and then the coffee, the solution part just flows down to the bottom, and then the coffee grinds stay at the top. So that's really a very practical type of separation that we do a lot, every day. And another way to separate a solid from a liquid would be to take the substance that contains both the liquid and the solid. Let's put it in either a test tube or some kind of this is what we call a centrifuge tube. And basically what you do is centrifuge, or you spin them. So the centrifuge works by way of pulling, with a certain amount of force, the material that's more, that has more mass would be pulled down more versus the one that doesn't have as much mass. So, and as a result, the solid usually get pulled down a lot more compared to the liquid, and there's a separation. So at the end of that period of centrifuging or spinning, we call it, you can then pour out the solution component of the mixture and then leave the solid behind, and that's called decanting. Okay, so it's centrifugation followed by decantation would be another way to separate a solid from a liquid. Now, what happens if you have two liquids? Okay, now that might be a little difficult because you can't use filtration, because if you pour a mixture of liquids into filter paper, everything will go through. Okay, so you have to think about another way. Let's say you have a mixture of ethanol and water, like if you have like a alcoholic beverage, for example, like a beer or a vodka or something like that, where you have both water and ethanol mixed together and it's a uniform phase, how do you separate the water from the alcohol? Well, you can use distillation, and this is actually an important technique that you'll learn in organic chemistry. But the idea here is that ethanol or alcohol, drinking alcohol, and water have different boiling points. Okay, so they boil at different temperatures. So if I were to heat up the mixture containing both the alcohol and the water, one of the substances will boil first. In this case, the alcohol will boil first because it has a lower boiling point. It boils at about 78 degrees or so. So that one will boil first, and because it boils, it goes into the gas state. And then the gas will then, fill up, expand. Remember, gases like to fill up all the volume. So it starts to move all the way here and then get into this other container. Okay? Now, the difference here, as you can see, is that underneath this container you have your Bunsen burner, which means this is hot, and here you don't have anything, which is cold. Now, you can even make this under ice if you want. So once the gas gets here, because it's colder, then it condenses back, or it forms liquid again, okay? And so then you're effectively separating the water, because the water hasn't boiled off yet, from the alcohol, because the alcohol has boiled and then recondensed here to form the liquid ethanol. Okay, so this is a picture of somebody who's set this up, as a kind of a home distillation arrangement. But you can see that it's set up the same way, pretty much like this. You have some kind of a pan that's connected to a stove here, so that's the hot compartment, and this is the colder compartment. You have basically a path that allows the gas to travel from one hot compartment to the cold compartment. Okay, in the next video we'll talk about a couple additional separation methods.